Starting with number 3. Okay, so it's a matching game. So we're going to do 3, 4, 5, and 6. They want us to match the expressions in 3, 4, 5, and 6 with the letters A, B, C, and D. So the first one is the natural log of 6 minus the natural log of 2. Alright. So if I'm looking at A, B, C, and D, I see that these all say, like natural log of 64, natural log of 3, natural log of 12, natural log of 36. They're just natural log of a single thing. If you look at the properties, the product and the quotient and the power properties, we can use those to rewrite this. And since we're just learning this, just starting out, just take a stab in the dark by seeing, does this look like one of the properties? So I'm looking at the properties. I see that the only property that even includes subtraction is the quotient property. So I'm just going to use the quotient property to rewrite this expression. The quotient property says that I'll have a single natural log of the thing in front here over the thing that's being subtracted, or the thing that's over here. So here's the natural log of 6 divided by 2, which is 3. So I'm looking, natural log of 3, that is letter B, so we match it to B. So now the next one is 2 times the natural log of 6. So I'm looking at this, and I'm looking at the properties. I'm looking back and forth. I'm flipping between the homework page and the page that has the table of the properties. And I see the only one that has a number times the log of something is the power property. The power property on the right side of it has this going on. So what does the power property say that I can do with that too? Well, it says that I can pull it up and make it the exponent of 6. Forgive me while I need to keep track of my time. So 2 can become the power of 6. So this is the natural log of 6 squared. 6 squared is 36. Natural log of 36, that is letter D. Number 5, 6 times the natural log of 2. Well, it's the same kind of a situation as just before. This has a coefficient out here, and the only property that has a coefficient out in front is the power property. So we take 6 and make it the power of 2. 2 to the 6th is 64. So that is going to be A. Natural log of 64. Number 6, the natural log of 6 plus the natural log of 2. The only one of the properties that uses addition in any way is the product property. So following the example of the product property, in your books it's log base b of m plus log base b of n. And look at where the m's and the n's and the b's and all that kind of stuff wind up. And they will wind up looking like this. The natural log of 6 times 2. That's the natural log of 12. Natural log of 12 is C. Number 8 says that the log of 48. Notice I didn't say a base there. What base do I assume? Remember, if I don't write a base, I assume base 10, right? Now, the tools we're going to use is that we are given that the log of 4 is a number. The log of 4 is equal, well, is approximately log base 10 of 4. The power of 10 that gives me 4 is 0.602. So what it's saying is if I raise 10 to the 0.602 power, I'm going to get 4, or at least really close to 4. And also they tell us that the log of 12 is approximately 1.079. Alright, so what I want to do is use the power, the quotient, the product properties to write this in terms of the log of 4 and the log of 12. So what do we notice about 48, 4, and 12? What relationship do those numbers have? Well, I know that 12 times 4 is 48, so let's see what happens when I do that. 12 times 4 is 48. So I just rewrote 48 as 12 times 4. And what I can do is use the product property to rewrite this as the log of 12 plus the log of 4. Okay, what's the log of 4? Or, sorry, what's the log of 12? That's first. The log of 12 is 1.079, and what's the log of 4? It's 0.602. So, this is going to be, what, 11, 8, 1.6817. Get the log of 3. What do I know about 3, 4, and 12? And remember that the things that we can use are products and quotients and powers. All right? Remember that. Products, quotients, and powers. I'm going to show you a sample problem here in a minute that you're going to want to not use those things, but you have to use products, quotients, or powers. Use 4 and 12, multiply them together, divide them, raise one of them to a power, but that's all you can do. So 3, 4, and 12, what relationship do they have? Well, 3 is 12 divided by 4. So if I take the log of 12 divided by 4, it's the same as taking the log of 3. But I can use the power or the quotient property and write it this way. And the log of 12 is 1.079. The log of 4 is 0.602. So this time it's going to be faster. 0.477. All right, number 9. The log of 16. Now, in all of the classes, and it's very natural to think this, you look at 16 and you think 12 and 4, and you think, all right, 12 and 4. What can I do with 12 and 4 to get 16? Okay, so the log, you're thinking maybe, the log of 12 plus 4, 12 plus 4 is 16. So yes, and then I think addition, and I use the product property, but hold on. Look at the product property, and notice that inside here, it's called the product property because we're taking the log of a product. This is not a product. This is a sum. So there is no property. Look at the properties all day long. You won't see a property that has an addition inside the log expression. So this is no good. So what can I do then? Well, I think that the difficult thing is thinking, well, I have to use 4 and 12. But you don't have to. All you have to do is be able to write this in terms of 4 and 12, or 4 alone, or 12 alone. And think about 16. It's log of 4 squared. Right? 4 squared is 16. Now you look at the properties and you see there is a property that has, you're taking a log of something raised to a power, and that power becomes the coefficient. 2 times the log of 4. This is 2 times 0.602. This is 1.204. Okay. Let's do one more. Let's do 13. The log of 1/4. Log of 1/4. Look at your product to quotient, your power properties, and you'll see this is the quotient property. It's a quotient of two things. The log of 1 minus the log of 4. And you might think, well, I don't know the log of 1. But remember, you do know the log of 1. 10, what's the power of 10 that gives me 1? And this is one of the properties of logarithms in general. If you have the log base of anything of 1, what's the power of anything that gives you 1? Well, anything raised to the 0 is 1. So log base anything is 1, of 1 is 0. Minus 0.602 is given. So negative 0.602. Okay. Let's take a look at 15. It says expand the expression. Expand the expression in short means take this, if it looks like the left side of one of the properties, make it look like the right side. And once everything looks like the right side of a property, that's the side we would call expanded. It's expanded. So let's do that. How can we take this, if it looks like something that's on the left side of the properties, let's take it and make it look like the right side of the properties. So this looks like the left side of the product property. So let's take it and make it look like the right side of the product property. So this is the log base 3 of 4 plus log base 3 of x. All right, we look at it again. We just want to make sure we're done. This looks good. There's no powers here. There's no products here. There's no quotients here. There's likewise no products, quotients, or powers here. So we're done. So let's move on to 17. Log of 3x to the 4th. Okay, this is a big mistake I've been seeing all year. This 4th power only applies to the x, not to the 3. If I wanted it to apply to the 3, I would have to tell you that it applies to the 3 and put parentheses around it. But there are no parentheses, so that the 4 is only for the x. Okay. So what do we have here? Well, we might look and say, well, we got the power property, but we don't have the power property. Not yet. Because the power property is for this whole thing right here that you're taking the log of raised to a power, and that's not the case. Only the x is raised to the 4. So what do we have? Well, we have a thing times a thing. And a thing times a thing is called a product, and that would be the product rule. So let's follow the product rule. Log of the first thing, 3, plus log of the second thing, x to the 4th. Now let's take a look here. No powers, no products, no quotients, no way to rewrite this. Come over here, though. No product, no quotient, but there is a power, x to the 4th. There's no way to rewrite this part. That stays the same. But this, so how do we rewrite that? We're looking at the power property. The power right here becomes the coefficient. Log of x. Okay, so we're looking here. Neither of these looks anything like the left side of those properties. No products, no quotients, no powers, no products, no quotients, no powers. No way to rewrite it, so we're done. Okay. Let's go to 28. The natural log of 6x squared over y to the 4th. All right. So, all sorts of stuff is going on here. We've got powers and products and quotients. Everything is happening here. But we got to make sure that we do it in the right order. All right. So let's do that. The thing we need to be careful of is you might want to use the power property right away and just say, oh, a 2 comes down here. But remember, it needs to be the whole thing that you're taking the log of to the power, but it's not. Neither is the whole thing to the 4th. Also, you might want to try applying the power property, or the product property here, because it's a product, but be careful with that because you don't want to do it all in the wrong order. Let's look at the biggest thing that's going on. We got all of this divided by all of this, right? That is a quotient. It's a thing divided by a thing. It's like the most outside function that's happening. So let's use the quotient property because this is a quotient. It's a thing divided by a thing. So using the quotient property, we use the natural log of the numerator minus the natural log of the denominator. Okay, now let's look at each of these individually. This one's really easy. Let's look at this one first. It's just y to the 4th, right? So quickly, power property, right? So natural log of 6x squared minus 4 times the natural log of y. We use the power property to take the 4 down in front. Now with this is very similar to this one. This is 6x squared. This was 3x to the 4th. Remember that you can't just take 2 down here because it's not the whole thing squared. It's just x squared. So let's use the the product property first. Natural log of 6 plus the natural log of x squared minus 4 times the natural log of y. Now this one's done. No anything there to be applied. So natural log of 6 plus, but we do have the power property happening here. Minus 4 natural log of y. Okay, and we're all done. There's nothing left to simplify. Okay.